Alright, so for numbers 9 through 21, 21 I'll write in later, you have to convert from one form to another, from logarithmic to exponential, or from exponential to logarithmic. So right now on number 9, it's in log form, so I've got to change it to exponential form. Okay, so then the base is 7. The exponent is -2. And it equals 1 over 49. See, it's true. For number 12, the base is 16. The exponent is 3/4. And it equals 8. And that's true because the fourth root of 16 is 2. 2 to the third is 8. On 15, we go the other way. They give you the exponential, and you write it as a log form. So we write log base 5 of 125, and remember, on the other side of the log is always the exponent. So on the other side of the equation of the log, this is the exponent, which is this one right here. So 18 log base 9 of 27 is the exponent, 3/2. Okay, so 21, it says g to the a equals 4, so you're going to say log, the base is g, the exponent is a. Okay, so remember, log equals exponent. Alright, so for number 24, we have to evaluate the function. So log base 16 of 1/4 equals what? So remember, we're looking for, just make that an arrow first. We're saying 16 to some power equals 1/4. Well, I know I can write 16 as a base 4, so that's going to be 4 squared. And I could write 1/4 to the base 4, 4 to the -1. So then 2 times something equals -1. Well, then that equals -1/2. Okay, for number 27, we need a calculator. And because there's no way you can solve that without a calculator, because it's saying, this is saying 10, I'll get the marker, saying 10 to some power is 345. Okay, so you don't know what the power is. And base 10 is, your calculator's programmed with base 10. So remember, I don't know, the book, most books don't even write the base 10, they just write it log 345, and you're supposed to know that you take your calculator because that's the base on the calculator. So log base 345 equals 2 point, and to specify how many decimal, 3 decimal places, so 2.538. So number 30 is another calculator problem that they want you to evaluate. So it's 1.9 times log base 10 of 4.3. So it's the same thing as 1.9 log of 4.3. So you don't have to have the base 10. So just put it in your calculator just like you see it, and it should give you the answer of 1.204. And so remember, this is saying this is the x value that would go here. I'm sorry, this is the exponent that would make this function true. Okay, I forgot to put this here. So on 33, we're solving for x, and remember, we have a property that says if the base, this base, and this base is the same, then this log just equals 2. So 2 equals x. Alright, so 36 is a little different. It says log base 4 of 4 cubed equals log base 4 of x. Again, there's a property. We wrote it in today's notes that, as a reminder, that if the bases are equal in an equation, then that means these numbers right here are equal to each other. So then we write 4 to the third equals x, which means 64 equals x. For number 39, I'm going to simplify this part, and then whatever I get, I'm going to multiply by 3. So log base 2 of 1/2 is, you're saying 2 to what power equals 1/2, right? So that means that that equals -1. So 3 times -1, because this whole box right here, this is -1. So 3 times -1 is -3. Okay, so for number 42, they want you to graph f of x and then use f of x to graph g of x. So I went ahead and I put the reference points for f of x, which is -1, 1 over b, 0, 1, and 1b. So -1, 1/5, again, just approximate, 0, 1, and 1/5. So connect the points. And this is f of x. Okay? For g of x, all I'm going to do, because notice they are inverses of each other, I'm just going to switch the x and the y, okay, of the reference points that are on the screen. So instead of -1, 1/5, I'm going to put 1/5, -1. Instead of 0, 1, I'm going to put 1, 0. Instead of 1, 5, I'm going to put 5, 1. And then connect. So this one is g of x. Okay? By doing that, again, notice how the two graphs reflect over the y equals x line. Okay? This is the line of symmetry for the two graphs. Alright, so for 45, they want you to give the domain, the vertical asymptote, x-intercept, and graph. Okay? So let me go ahead and I'm just doing the preliminary stuff to graph it. So if I wrote down the reference points. The x plus 2 means that h is -2, so that means the graph is moving to the left 2 units, so we have to subtract 2 from all the x's. So that gives me -1, 0, and then 8, 1. Okay? I know the vertical asymptote is going to be x equals -2, because that's the h value. And I know that the domain is going to be, and I could do it after I graph it, but I know it's going to be from -2 to infinity. Okay, so let's go ahead and graph. Okay, so vertical asymptote is x equals -2, so I'm just going to go ahead and draw that in first. And then the points on the graph, -1, 0, and 8, 1. Okay, so this is a very, very steep curve. It still should be a curve. Don't draw it. Why isn't it showing? Get closer. Oops, I missed the dot, but that. Okay. So for this problem, the k is 2. The a value is -1, so there is going to be a reflection over the x-axis. So they're both affecting, the two parameters are affecting the y coordinate. So it's going to be -y plus 2. The x stays the same. So it's going to be 1, 2, oops, that's happened. Sorry, went to the other page. 1, 2, and then 10, -1 plus 2 is 1. Okay? And the vertical axis is x equals 0 because h is 0. Okay? And the domain would be, well, let's graph it first, then I'll answer the domain. Let's see. So the vertical asymptote is on x equals 0, so it goes right here. And then 1, 2. And then 10, 1. Okay? Now remember, there's a reflection on the x-axis, so it's going to go like this. And it does go down slowly. So just like in the example in the class, this here is not a horizontal asymptote. Okay? It's not. It's going to cross at some point. Let's see. When does it cross? At 100. At 100, 0, it's going to cross. So there's no way I'm going to show it on the graph. Okay, but it will cross. So let me just make a little note. At the point 100, 0, it's going to cross. Okay, so quite a ways, but it will. Alright, so for 51 to 54, you have to match. I forgot to take a picture of the graphs, so just use your book, right? So 51, the transformation is k is plus 2, positive 2, so that means the y's move up. The y's change by increasing by 2s, right? So the new points would be 1, 2, and 3, 3. So the graph that shows that would be B. For number 52, you've got negative in front of the log, so that's the A value, so the Y changes sign. So then you have the 0.10 and 3, negative 1. So it reflects over, the graph reflects over the x-axis. So that one would be, reflecting over the x-axis with those coordinates, would be C. Number 53, the H is negative 2 and the A is negative 1, so the X's go to the left one, the Y's change signs. So you have 1 minus 2, negative 1, 0, and then 1, negative 1. So there's a reflection over the x-axis with a shift to the left. So that would be D. For number 54, I had to make a little change the way it looks. It's still the same equation, right? But I factored out a negative 1 from the x right here. So when you factor a negative 1, you get this. And the reason for that is to show the parameters in the way we're used to seeing them. So right here, b is negative 1, and when I say b, I'm not talking about the base b that I've been using, but the b in the transformation is a parameter b, this one. And then h is positive 1, so that's why it shows it right here, negative x plus 1. So when you do that, you get negative x is negative 1 plus 1, that's 0, 0. And then negative 3 plus 1, that's negative 2, 1. And so the graph, of course, is the only one that is missing, that we haven't marked, right? But I do want you to look at the graph and confirm that it is 0, 0, and negative 2, 1. There is a reflection over the y-axis. That's what the negative in front of the x does. Okay, so that would be A.